let's talk a little bit about SOHCAHTOA. If you haven't learned this previously, SOHCAHTOA, we're going to talk. We are in lesson 12.2, and we're working with trig functions. And we a lot of times see 6 trig functions, and what that means are the following. We have the sine, which is opposite over hypotenuse. And that's where the so comes from. I love that little saying, SOHCAHTOA. Cosine of theta. This is a Greek symbol, theta. And you're going to start seeing a lot of Greek symbols and just get used to learning new symbols. It's just like an X, the angle theta, and that is adjacent over hypotenuse. And tangent of theta is opposite over adjacent. And when we say 6 trig functions, we have some new words for you. So SOHCAHTOA you probably did in your geometry class, but you may not have worked with the cosecant yet. So the cosecant of theta, notice we just take the sine and we flip it. So it's hypotenuse over opposite. The secant of theta, we take the cosine and flip it, hypotenuse over adjacent. And the cotangent, and I'm just writing these out so you could see them, of theta is equal to the adjacent over the hypotenuse. Now what does that mean? We're looking at this triangle right here, and we call this angle theta degrees. If this is theta, the opposite would be straight across. The adjacent is a line, or the side right next to it that's not the hypotenuse, and the hypotenuse is cross from the 90-degree angle. So let's apply some of these. The first thing I always encourage my students is to know your Pythagorean triples. So Pythagorean triples are in the form a squared plus b squared equals c squared. This is a middle school concept that you probably learned, but I make you memorize actual triangles that I see all the time. So a 3, 4, 5 is a perfect Pythagorean triple. 9 plus 16 equals 25. And also remember that any multiple thereof, a 6, 8, 10 is everything multiplied by 2. A 9, 12, 15 is anything multiplied by 3. So those are all considered 3, 4, 5 triangles. A 5, 12, 13 triangle, again, is going to fulfill that a squared plus b squared equals c squared. A 7, 24, 25 triangle, and an 8, 15, 17. Now, I always tell my students the only one you really have to memorize is this one. And here's why. I have these fancy little tricks for you. If I take any odd number, 3, 5, 7, 9, 11, let's just do 3. And if I square 3, I get 9. If I was to split 9 the best I could, without going into decimals, I would have 4 and 5, right? So I know that a 3, 4, 5 is a perfect Pythagorean triple. It's just kind of a fun, excuse me, kind of a fun trick to know. Let's look at 7. 7 squared is 49. Split 49 the best you can, 24, 25. And it also lets you remember, oh yeah, 9 squared is 81. Oh, I know that a 9, 40, 41. Now this isn't one that I see all the time, but it might come up. Let's move to the 6 trig functions of angle theta whose terminal side passes through point 3, 4. So if I had to graph point 3, 1, 2, 3, 1, 2, 3, 4, that would be here. And we're talking about the unit circle, where I know everything on the unit circle travels counterclockwise. So notice that I just traveled counterclockwise, where this is 0 degrees, this is 90 degrees, this is 180 degrees, 270, and back around is 360 degrees. So this is the triangle that we're talking about, but we haven't made a triangle yet. So please note that you have to make all triangles, draw triangle to the x-axis. Take a note on this, star circle highlight, because when I draw it to the x-axis, notice I made a right triangle. And we're going to call this theta. Let me mark it in a darker color. This is theta. But we already know that this side is 3 because that side of the triangle is right there, and this side is 4. Ooh, ding, 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 ding. I know that this is a 3, 4, 5 triangle. So let's fill in the 6 trig functions that we know. Sine of theta, opposite, which is 4, over hypotenuse, which is 5. Cosine of theta, opposite, JK, adjacent is 3, 3 over 5. Tangent of theta, opposite is 4, over adjacent is 3. Now, if you could remember that cosecant is just the flip of the sine, that is wonderful. Cosecant of theta is 5 over 4. Secant is just the flip of the cosine, 5 over 3. And tangent of theta, we know the flip is the cotangent, which would be 3 over 4. All right. Find the following if alpha, this is a funny looking Christian fish that we've seen probably in Bible class, is an acute angle in the sine. So it doesn't matter which way you draw your triangle, but I'm going to draw it. And you know what? I'm going to put alpha here because I have a lot of people saying, well, you draw them all the same. If this is alpha, the opposite, so, is 5 over the hypotenuse, which is 13. And because of what you know this is a 5, 12, 13 because your mean math teacher made you memorize the Pythagorean triples. So moving into the cosine of alpha is adjacent, 12, over hypotenuse, 13. The tangent of alpha is opposite, 5, over adjacent, 12. So I have my sine, cosine, and tangent, my SOHCAHTOA. Not so shabby, huh? And those are your 6 trig functions. Don't forget you're going to work with all of them. Sine, cosine, tangent, cosecant, secant, and cotangent.